Okay, so this is going to be the solution for the quiz we took the other day on the Mythbusters episode. I have all of the picture for the problem laid out with all the given information on it. The ramp was an angle of 30 degrees. It was 4 meters off the ground where the guy was launched from. And it's to travel a horizontal distance of 35 meters. What we're looking for here, of course, is the initial velocity. I've indicated my positive directions here as up and to the right, and I've already gone ahead and written down the easy parts of what we know. We know the vertical and horizontal displacements. We know the vertical and horizontal accelerations. Now we don't know the magnitude of the initial velocity, so we can't write down a number for the initial x and y components of the velocity. But what I can do, of course, is say that once I figure it out, I could do this calculation, v cos theta for the x component and v sine theta for the y component. Now what that gets me, it doesn't seem like it actually gains us much because it's still something we can't calculate, but what it does gain me is before I had two values that I didn't know. I had two unknowns, okay, v naught x and v naught y. By writing it this way, because I know theta, I now only have one unknown, right? And that one unknown is the magnitude of v naught. Okay, so I've eliminated an unknown value by writing it this way. Okay. So it's not going to follow the normal procedure, at least it's not going to look like it's the same procedure as our other projectile motion problems when we do know the initial speed. It's going to look a bit different. Okay. So, critical piece, of course, is to find the time. So what I'm going to do is, in the y direction, use the first kinematic equation, which is this: y equals 1/2 at squared plus v naught y, of course, t plus y naught. I should indicate also that the acceleration is in the y direction. Okay, so I'm going to sort of pull kind of a trick here and just say that when I move y naught over to the left side here, what I'm going to get is y minus y naught, right? So and that would be delta y. So I'm just going to go ahead and plug in -4 there, just to save myself a step. 1/2 times 9.8 t squared plus, so my v naught y, remember, I wrote down as v naught sine theta. So I'm going to go ahead and plug that in. Times t plus 0. So I already took care of the change in position. Okay, so I've got an equation here, but I'm now with two things that I don't know. I still don't know, of course, v naught, but I also don't know how much time it took. So I'm going to come back over to the x part and come up with another equation. Well, for x, I have no acceleration, so I can use the average velocity equation. Okay, but I'm going to do something a little bit tricky. I'm going to solve this for time. I'm going to go ahead and plug in cos theta here. I'm going to solve it for time. Okay, so I have time equals 35, which is my delta x, over v naught cos theta. All right. I've got another equation here, though, that still has two unknowns. But if you look closely, the two unknowns in the two equations are time and v naught. So I've got two equations with the same two unknowns. That is a solvable situation. You should know from math class that for every unknown, you need an equation. If you have three unknowns, you need three equations. If you have one unknown, you only need one equation. So here we've got two equations and two unknowns. A couple different ways to solve this. You could solve each one for t and set them equal to each other, but because this one is a quadratic, I think that's not the easier choice. So instead, I'm going to substitute. I'm going to take this, plug it in for time in both of these places. Okay, that'll eliminate time as a variable, and allow me to solve. Okay, so here I would have time, so I'm going to go ahead and plug in 35 over v naught cos theta squared, because that time is squared right there, plus v naught sine theta, which was there before, right? That was here already, times time, which again I'm subbing in for v naught cosine theta. Okay, so this actually becomes a pretty simple calculation from here. A couple things to simplify. One, I have v naught on top and v naught on bottom. Those will cancel out. Okay, this now just becomes a number I can calculate. I can plug in for theta in both places and plug in 35. You can go ahead and square all these. I'm not going to go through all the algebra steps. I think you guys are pretty capable of that. And when you do it all out, you get v naught is about 18.2 meters per second. Considering how much everyone struggled on this, it's a pretty good bet that a question like this will be on the test. So hopefully you watched this and you get something out of it and be able to study even better now.